In the past two videos, we understood the process of making clusters through Euclidean measure of distance. In this and the next video, we will understand k-means clustering that uses Euclidean distance for making clusters. K-means clustering is the most well-known clustering method when the data is continuous or interval variable. K-means can also handle ordinal data, but for that we have to first normalize the ordinal data. We will go over the method of normalizing in a later video. Right now, we will focus on clustering continuous variables without normalizing them. Another thing to remember is that k-means cannot be used for clustering binary and nominal data. There are three features of k-means algorithm that you need to remember. First is that the number of clusters have to be provided at the beginning of the clustering process. As we already know, the number of clusters refers to the number of centroids. As of now, we would be randomly determining the number of clusters. In a later video, we would go through several methods that can help us in identifying the number of clusters that are best suited for the data. Second thing to remember is that each row in the data is assigned to the cluster or centroid that is near to the row. Third feature is that one row of data would only become part of a single cluster. Let's understand k-means clustering using a simple example. We will move to R for this. In the first line of code, I am creating an R object that contains 6 elements 1, 2, 3, 4, 5 and 6. I want to make 2 clusters from these 6 elements. For this, I will use the k-means function that allows us to perform k-means clustering. First argument in the function is the R object containing the data that is needed to be clustered. Second argument is the number of cluster that we intend to make using the data. Here, I have set the argument to 2 for making 2 clusters. I am saving the output of the k-means function inside an R object B. There are several components in the clustering result. To access these components, we can use the name of the object followed by $sign and the name of the component. Let's go through the components one by one. First component is cluster, which returns the cluster that each data point belongs to. Just by looking at the data, we already know that 1, 2 and 3 would make one cluster and 4, 5 and 6 would make the other cluster. As you can see, we have got the same result that was expected. First cluster is made from the first 3 numbers and the other cluster is made from the last 3 numbers. The next component is centers, which gives the mean of each of the clusters. First cluster contains the element 1, 2 and 3. The average of these numbers is 2. Similarly, the second cluster contains 4, 5 and 6 and the average of these 3 numbers is 5. So the value returned by the centers are 2 and 5. Let's move to the next component, which is size. Size returns the number of elements in each cluster. In this example, each of the 2 clusters contain 3 elements each. The same result is being displayed on the output window when we are accessing the size component. The next component, totes, represents the sum of the square difference of each element in the data from the mean of the data. Totes is the short form for total sum of square. Let's understand this component. The mean of the 6th observation is 3.5. One by one, each observation is deducted with 3.5 and squared. Finally, all the square differences are added to get the value for total sum of square, that is 17.6. Let's move to the next component of clustering result, known as withins. Withins can be expanded to within sum of square. Withins represent the sum of the square difference of each element of a cluster from the cluster mean. Let's understand this using our example. For getting the value of within sum of square for the first cluster, each element of the first cluster is deducted with the mean of the first cluster, that is 2. The 3 differences would then be squared and finally added to get the value for within sum of square for the first cluster. In the same manner, to get the value of within sum of square for the second cluster, each element of the second cluster is subtracted with the mean of the second cluster, that is 5. The square of these differences are added to get a value of 2. Needless to say, there would be as many values of within sum of square as the number of clusters. For example, since we asked the k-means function to make 2 clusters, we are getting 2 value of within sum of square. Let us go through the final element of k-means function, namely betweens. For arriving at the value for betweens, we need several values. Let's look at them one by one. First is the mean of the 2 clusters, which is 2 and 5. Now, we would subtract each of the cluster means with the overall mean and square these differences. We would then multiply each of these square differences with the number of elements in their respective cluster. Finally, we would add these two resulting values to arrive at between sum of square, which is 13.5. We will cover the significance of total, within and between sum of square in a later video. In the next video, we would use the IMDb dataset taken from Kaggle. We would make 4 clusters from this data using the k-means function. Then, we will understand the results of this function.